The instant noodle process. Billionaire starts here, with the rigorous selection of high-protein wheats, stored in controlled atmosphere silos. High-pressure pneumatic systems transfer tons of flour per hour, directly to the processing lines. A network of kilometers of stainless steel pipes ensures that no external contaminants come into contact with the raw material. We enter the heart of the processing plant, where automation reaches its maximum level of accuracy. Every gram of flour is heavy and recorded digitally to ensure the exact consistency of each batch. The flour passes through screens, ultra thin to remove any unwanted particles. Before mixing, lung silos maintains on production flow, even during load exchanges in the main hills. The automatic dosing system split the flour with a lower margin of error to 0.1%. A juniper of rare earths capture any foreign microparticles that may have originated in the transport. Simultaneously, the tired and essential promising solution is prepared to give to noodles. Its elasticity and yellowish color of the features. Chemical precision here is vital. Any deviation permanently changes the texture of the final product. Raw material and alkaline solution now converge to the first stage of physical transformation. Before production, kisses. High precisions are clean and calibrated automatically by self-cleaning systems. Injection takes place in fine mist, allowing each flour granule absorbs moisture in a homogeneous vacuum mix, removes air bubbles, resulting in a denser mass, smooth and strong. The result is Elid mass, known with Sobero, which has the exact moisture level for lamination. Posterior. Sensors. Opticians analyze particle size in real time to validate the homogeneity of the mixture. Dough travels on resting mats, where gluten begins to develop naturally about controlled conditions. Thermal wear is constant. The mass temperature must not fluctuate to maintain optimal elasticity. Inside the lighting tunnel, humidity is maintained at 90% to prevent surface dryness. Automated scrapers ensure that the treadmill is always clean, preventing the accumulation of waste between batches. The vacuum system is equalized, preparing the mass for the transition of the environment to atmospheric pressure. Elasticity test. Initial is performed by robotic probes, validating gluten strength before lamination. With the dough perfectly prepared and rested, we enter the critical phase of mechanical transformation. The first pair of rolls, compressors apply tons of pressure, turning the bran into a solid sheet of dough. This starting sheet is thick and irregular, but constitutes the structural basis of all the process. The double sheet process joins two layers of mass, reinforcing gluten chains for a texture. To the upper tooth, consecutive sets of rolls reduce the thickness of the dough progressively, increasing its density and smoothness. Laser sensors measure thickness with micro precision, automatically adjusting roller pressure. As the mass thins, treadmill speed increases to maintain continuous flow without causing ruptures. On the fourth stage, the mass reaches a sub-millimeter orbit, requiring absolute precision in the rotation of the cylinders. The surface is now perfectly lisa, ensuring that pasta does not absorb excessive oil during frying. The final stage defines the exact thickness of a millimeter, global standard for 3-minute cooking time. Jets of compressed air cool the cylinders, continuously preventing the heat of Africa. Change the structure of starch. High-speed optical equipment detects micro cracks imperceptible to the human eye. With the finished sheet, the dough now enters the cutting phase, where you will gain your iconic shape of threads. Precision rotating. Divide the sheet into hundreds of individual strands in a fraction of a second. In this brief instant, the wires are still straight and parallel, before creating your characteristic curvature. When finding a slower treadmill, wires undergo a controlled increases the waves that facilitate the circulation of steam. Separator teeth ensure that noodle farms remain aligned, avoiding tangled before cooking. The result is a continuous carpet of threads. A cell designed for maximum thermal efficiency. The curvature of each wire is calculated to allow steam to pass between the layers, cooking the center of the block. Pneumatic guides maintain alignment, yarn met centesimal, ensuring there is no waste on the edges. The flow is carrying thousands of kilometers of wires a day for steam cooking. A density sensor checks the frequency of waves, ensuring the final weight of each package is accurate. The blowers tires ensure individual waves remain separated, optimizing heat penetration. The of the wire mat is fundamental to uniformity, thermal that will follow. Adjustments, millimeter tires, correct carpet width in real time, preventing mass losses at the edges. Computer vision systems validate the integrity of each wire before starting cooking. Thermal protections keep the heat concentrated, preparing the dough for the impact of steam at 100 degrees. The isolation is total. Here begins the structural chemical transformation of the mass. With cutting and curling completed, the raw mass is ready for your first lawsuit, thermal cooking. We enter the steam tunnel. Here noodles are sensitive to an atmosphere, saturated for gelatin. Instant. The tunnel extends for 50 meters, ensuring residence time, accurate for complete cooking. Control valves keeps the internal temperature stable and accurate, 100 degrees Celsius. On this level, starch granules absorb water and break up it. Add the soft texture of the pasta ready. The fibers expand, filling the gaps in the waves, and adopt a structure porous and uniform. Sensors monitor color change, indicative, straight from the internal cooking level of the dough. Steel mesh mat allows steam to water under the wires, ensuring a firing of 360 degrees. Dozens of thermal probes map the tunnel, centimeter to centimeter, to avoid temperature variations. High pressure vaporization. It is applied at strategic points to ensure that the center of each block of mass be cooked evenly. Moisture control is mandatory. A fall, 5% would result in brittle wires. Vaporizer output. The noodles are now fully gelatinized, presenting its golden color and attractive appearance. High power exhaust systems remove excess steam to maintain visibility and factory moisture control. First post-cooking visual inspection. Texture should be elastic and waves perfectly preserved. An automated softness test validates the texture, ensuring the ideal chewing pattern. The initial quick cooling stabilizes the mass structure before applying the liquid seasoning. Spice preparation. The journey of flavor begins now. A vial of liquid seasoning bathes the threads, ensuring the flavor penetrates every curve of the mass. Flavor penetration is immediate, taking advantage of the porosity created during the vaporization. High-speed rotary cutters divide the continuous flow into blocks. Exact weight individual. Division into individual blocks. Accuracy here is measured in milliseconds. The mechanical fold gives the block its final shape. Compact, ideal for packaging and meals. Fit the molds. Each block is positioned with absolute precision for the final step of thermal dehydration. The alignment in the frying cups must be centesimal to prevent deformities during sudden dehydration. Light pressure adjusts the shape, making sure the block fits perfectly in the final container of the consumer. Each block is heavy in motion. Any weight deviation is corrected in batches, following automatically. Millimeter positioning adjustments prepare the flow for large-scale distribution. The stream now expands into 12 parallel rows, multiplying the productive capacity to millions of units per day. Arms ensure that each mold go into the fryer chain in exactly 1,000 in a second. Suction systems remove any mass debris, keep the production line free of contamination. In the molds, prevents noodles stick to metal while frying. With the blocks formed and aligned, we enter the heart of the factory, the flash fryer. Diving in palm oil at 150 degrees causes instant evaporation of residual moisture. This intense bubbling is the sign of dehydration. Flash reducing humidity by 30 for less than 5% in seconds. The journey through the fryer lasts exactly 90 seconds. Tempo, enough for the structural of starch. The creation of micropores. It's the secret of instant noodles. These channels allow hot water penetrate the block in minutes. Millions of blocks cross this heat zone daily. Increases global fast food supply. Continuous filtration and automatic reset. Ensure that the oil is always at its maximum level of freshness and purity. For each fried block, the system restores the exact amount of oil absorbed. Increases constant tank level. 90 seconds. Residence time is controlled by frequency inverters that guarantee the accuracy of 1,000 seconds. The color change signals the caramelization, partial sugars, and final cooking. From the mass. Emergency. Blocks let the oil bath. Now, completely dehydrated and structurally solid. High frequency vibrations. Remove excess surface oil. Optimizing the fat content of the final product. Industrial authors capture oil vapors. Choose factory environment clean and safe. The dough leaves the frying zone, moving from thermal darkness to the inspection zone. Finals. Acoustic sensors analyze block resonance, validating the crunch level and internal porosity. Pneumatic release releases the blocks, now transformed into units, crispy and ready to eat. We complete the thermal phase. Thousands of blocks now proceed to final stabilization and cooling. We enter the cooling tunnel. At room temperature, it is blown at high speeds to dissipate residual heat. EPA filters ensure that the blown air is free of any external impurities. Cooling is monitored by infrared. We reduce the temperature to 140 to less than 40 degrees. In a few minutes, fat stabilization is vital. Oil must become solid on the surface to ensure the validity of 12 months. Width and stable structure. The block is ready for the final stages of assembly and packaging. The ionized air removes any microparticles, surface residuals, guaranteeing in final product. Air is continuously filtered by units. High efficiency EPA. Discover the stereo environment. Multi-level scissors. Maximize cooling time in a physical space. Optimized. Deviation systems. Direct blocks for different packaging lines. Simultaneously. O sensor final validates humidity below 5%, ensuring the crunch and durability of the product. Blocks are selected randomly by robotic test system. Laboratory destructives. The breakage test confirms the structural integrity, ensuring noodles resist global transport. We start the transition to the clean assembly zone, where seasoning sachets will be integrated. Hundreds of baskets per minute are processed in sync with noodle flow. Each sachet is verified. The absence of a single item breaks the line. Instantly. We complete the final treatment. We enter the final assembly zone, the penultimate stage of production. Assembly begins. Each flavor sachet is accurately deposited, absolute over the center of the block. The industrial scale reveals itself in 12 parallel lines, operating in perfect mechanical harmony. Delta robots perform up to 200 movements per minute, positioning ingredients additional with millimeter precision. The perfect centering ensures that the packaging seal is not choose by items out of position. The definitive union, the block and its condiments enter the enveloping tunnel, where the plastic film is molded around the product. Constant voltage systems prevent the film from breaking, operating at speeds of hundreds of packs per minute. Vertical thermal sealing joins the edges of the film. Put a wrapper, initial airtight around the noodles. Nitrogen injection. The pillow effect protects the crisp block from harmful impacts. During logistics, rotating jaws perform final sealing and cut it at high speed, ending the physical union of all the components. Laser coating. Batch and validity are confirmed. Indelible for full traceability. O river of finished packages flows to the final inspection zone, the ultimate test of the billionaire factory. We complete the assembly. The product is now ready to face the most delicate quality tests. Industrial quality control here. Cutting-edge technology ensures that 100% of products meet global security standards. High-sensitivity metal detectors scan every unit in search of ferrous and non-ferrous particles. X-ray inspection identifies low-density contaminants like glass or plastic, invisible to conventional detectors. High-precision dynamic weighing. Any unit outside the sampling margin is deviated from the main line. Pneumatic rejection is instantaneous, ensuring that only absolute perfection proceed to final packaging. Sporadic manual versions validate the accuracy of graphic arts and physical integrity of the sellages. A final step of cleaning. Remove any static waste. Preparing package for sanitary packaging. Sealing integrity tests. Ensure that the nitrogen atmosphere remains intact all the time from shelf. Packing samples for each batch are archived, allowing complete traceability up to 2 years after manufacture. Final assembly approved. Product leaves quality control towards secondary packaging for distribution. The logistics phase begins with the grouping. Automated packages. Individual in commercial batches. Box gunners operate in millimeter synchrony, preparing the casing for mass transport. High-load robotic arms perform the invase, ensuring the integrity of individual packages. Sealing by hot meltable coil. Closure is immediate and permanent, shielding the cargo. Automatic tagging. Each box receives its digital identity for real-time tracking. In distribution centers, robotic palletization. Thousands of boxes are organized in load structures, ready for global shipping. Stretch film involvement protects the load from moisture and ensures absolute stability during rail or sea transport. Welcome to warehouse for vertical crushing. Automated cranes move tons of charge vertically in seconds, operating 24 hours a day. From loading docks, the product starts its journey to hundreds of countries, feeding billions of people around the globe. Simple for those who consume, but the result of one of the largest and most complex feats of modern industrial engineering. The billionaire factory never stops, feeding the world, one package at a time.